Before I start my presentation, let me give my grateful to the committee that worked so hard to continuing preparation of the conference, even though in the condition like this. So we have doing the conference by online. Let me introduce myself. I'm Faisal, the student of University of Indonesia, and as the first author for this paper with title Effect of Connected Nonlinear Household Appliances on the Disturbance at Frequency Range of 9 to 150 kHz in the on-grid photovoltaic system. Okay, we start with the introduction from this paper. First point, I want to explain about disturbance. Disturbance is the higher frequency of harmonic, usually above 2 kHz. And as we know, harmonic is the distortion of waveform that generating at frequency range 50 to 2 kHz. When we are operating the electronic or electrical devices, it also some of other signals are generating. In this case, either the disturbance or harmonic is the unintended signal or distortion waveform at the frequency range that I told before in the previous point. The second point is frequency. Scope of this study is at the frequency range starting 9 kHz to 150 kHz. First of all, at this frequency range, some of other researchers reported that there is some disturbance generated in the on-grid photovoltaic system. And on that research was using pure load like resistive, inductive, and capacitive load. Moreover, at this frequency range is usually using for PLC or power line communication. Also, at this frequency, there is no standardization about the emission of this disturbance. The third point or the last point, scope of this study is more focused on investigating the disturbance using household appliances, especially induction cooker. Inside of these induction cookers are installed the power electronic components and also reported by other researchers that those are power electronic components were generated harmonic. Therefore, on this study, we are aiming to find the disturbance from these household appliances. Okay, in this slide, I want to explain about the flow diagram of this study. We are doing this research with three steps. First step is the system. Before we start the research, we learned of all the things that has relation with the systems. After that, we are preparing the components that will be installed or connected to the systems, such as the photovoltaic, inverter, and other tools, especially the tools that we have to do the measurement and then is creating the system. The second step is measurement. The first measurement is measuring the age of disturbance characteristic of household appliances load, and after that measure the and take the data from the combination of two induction cookers. The last step is the data processing. After measured and got all of the data, uh, then the data processed by using FFT method on MATLAB software. FFT method is fast Fourier transformation. This FFT process is converting the x-axis and y-axis from sinusoidal waveform that contain time and voltage to the frequency and voltage, because the data that we would see are the dominant disturbance and the frequency of the disturbance. After that, we analyze the data to find the changes of the disturbances values and frequency. The next slide is measurement method. As all of you can see on this slide, this is the picture of measurement scheme and the position of measurement tools. The first tool is picoscope that the tool is using for measure and take the disturbance data at frequency 9 to 150 kHz. And the tool is placed on the inverter output that connected to the loads. This picoscope also connected to the PC or personal computer, so we can take and process the data in the PC. Before that, we installed the high pass filter to cut off the other frequency so we can get the frequency that we want above the 9 kilohertz. The second tool is PQA or Power Quality Analyzer. We only use these tools for measure and confirm the data of power usage from equipment under the test. This tool also placed on the inverter output without passing the filter. In this slide, contain about how we do the measurement. Firstly, we measure the disturbance characteristic of each load. As you can see, this is the power that we used in the study for each load. For induction cooker brand A, the power usage are 100 watt, 200, 300, 400, 500, 550, 600, and 800 watt. For induction cooker brand B, the first power level is 100 wattage, 400, 1000, 1400, 1800, and the last power usage is 2100 watt. After we measured and got the disturbance characteristic of each induction cooker, the next step is we find the combination of induction cooker disturbance characteristic. On this combination load, we use two methods. The first one is using power usage variation, and the second step is raising the power of each level. With the power usage variation, we are using this combination. The first point is combination using variation power with 100 watt, 400 200 watt, 400 400 watt, 1400 watt, 1800 watt, 2100 400 watt, and 2100 with 800 watt. In the second point, we are using combination by rising power, and with raising power level we use power that can be seen in the table. In this slide, result of the data that we got from Picoscope and processed by MATLAB is just like this, like the picture in this slide. In this graph, with x-axis is a frequency and y-axis is voltage disturbance. And in this data, there are 5 data that are selected. This is the data of the most dominant for the several measured data samples. After the data processed and we got like this, it is more simple than previous slide, so the data is easier to analyze. In this graph, we can see that the disturbance value from each load. This is for brand C. The trend of this graph is increasing on each power level, but suddenly decrease at the end of power level. Next slide is the picture of graph from disturbance value of each power level in induction cooker brand P. The trend of this graph is the disturbance always increasing as the power level increasing. Okay, after we got the measurement data of each load in the previous slide, we do the measurement and take the data for combination load. The picture in this slide is the graph of combination load using power usage variation. Because we use random power variation, the trend of this graph also looks random. As all of you can see, in this graph's trend, the disturbance value is changing. Either it's increasing or decrease. Okay, for the next slide, this is the graph of disturbance changes from combination load and using power level method. Can be seen that trend of this graph is the disturbance value increasing as the power level increasing. From the graph on the previous slide, the data is processed. Then we got the value like on this table, can be seen that the value is increasing, so we can do the analyze from percentage of the disturbance change. The next analysis is you can see on the table in this slide. This is the table of percentage for disturbance changes from previous slide. At the column 3 and 5, the negative value is the opposite from column 2, 4, and 6. It means the negative values is the increases of disturbance values. Okay, for the last slide is the conclusion. The conclusion that we can get from this study, the power consumption of connected appliances may cause changes the disturbance generated by appliances in the system. The disturbance generated by the appliances could be higher or lower dependent on the disturbance behavior generated by the appliance responding to the system. The effect of connected two types of induction cooker is only for equipment used in this measurement because every appliance has unique disturbance, behavior, and component. So the effect of connected other appliances may get the different results. In this slide is the references that we use for research. There are some of references that we use. This is the last part of the presentation. Thank you for your attention.